configuration. So if you look at this side of the board and you don't understand or you're confused or it seems like what is that all about, you probably need to watch the previous video where we begin the lesson on electron configuration. So this is just a continuation of it. Don't watch this until you've learned this concept over here on the left. I put it up there as a reference, just as a reminder for what it is that we're learning about. Just as a quick recap, we got quantum numbers, which are the big numbers in the configuration. That tells me the principal energy level. There's 4 main ones, but it can actually go up to 7, as we can see on our periodic table. Then you have sublevels, which are represented by letters in order S, P, D, and F. S being the smallest, also defined by shape, S for spherical, P for two-lobed, and so forth. So that is the representation of sublevels. Every sublevel has orbitals as well. They're synonymous. And depending on the letter, it will also tell you how many sublevels and the orbitals within it. So this is important for our lesson today. So make sure you pay attention to that. S will always have 1, P will always have 3, D will always have 5, and then F will always have 7. Remember that every orbital can carry a maximum of 2 electrons. A maximum of 2 electrons, which means you're basically going to multiply it by 2. So the S orbitals can carry up to 2 electrons, P up to 6, D up to 10, and then F up to 14, obviously. You're just going to multiply it by 2. That's important because of what we're going to learn about here in a second. This is just a dissection of what it is when you see the configuration of particular elements. You see the big number, once again, is the quantum number for your principal energy level. The S will tell you the sublevel, what block it is in. Remember that the furthest 2 columns to the left are your S block, then the furthest to the right, starting from 13 all the way to 18, those columns are your D block. In the middle, your transitional metals are your D block, and towards the bottom, the 2 extending columns at the bottom, that's your F block. So you have S, P, D, and F. We'll talk about the D block and the F block later on. We're focusing on the first 20 elements. By the way, before I forget, I know that you've received several worksheets, and if you're watching this, then that means that you're gonna pay attention and you're gonna listen and you're not gonna be confused and rushing trying to finish something you may not understand. So unless you're 100% sure you know how to complete all of the worksheets, those are not due till next Thursday. So I'm going to extend one more week for you. Today is Wednesday, the 28th of April, so it'll be extended till next Thursday just to make sure we fully understand. Along the way, though, I am going to give you quizzes starting tomorrow on the configuration. So please make sure you're prepared for that. It's gonna be a lot easier at the beginning, and then as we progress into the lesson, then of course we're gonna put everything together. So at the beginning it'll be easy, no worries, but you do need to pay attention. And if you're listening to this, that means that you have another week to do these worksheets. Do not turn them in unless you fully understand. You obviously need the periodic table and the list of your electrons, so don't turn that in to me, okay? If you do need a copy of that, please let me know and I can send you a picture of it, or I can send a copy home in case you need that as a reference. There's a few of you that have turned that in. There's no need for that, just as a reminder, okay? Then the small number, continuing back to this, a small number will tell me how many electrons I have within that sublevel. So it's pretty simple. Remember yesterday we wrote out the configurations for the first 20 elements. That was your homework assignment. I need you to go ahead and either turn that in, drop it off, or send a picture of it to me. Either one is okay. That is an easy homework assignment. So please make sure that you come drop it in. You send it with the people that pick up your work from the Chicago students, or please make sure that you email a picture of it. I need the configurations of the first 20 written out, otherwise you're gonna receive a 0 for that. Now we're actually going to talk about what you call the orbitals, or the box orbitals, the orbital diagram. Just as a recap, an orbital is almost like a map to calculate where the electrons are. The further you move away from the nucleus, the more distance there is, and the more difficult it is to calculate exactly and to determine where the electron is. Remember from yesterday, we talked about how it's It's not impossible, but for the time being, we don't exactly know the exact location of every electron at any given moment. These are just diagrams. These are actually a lot easier than doing your configuration. They do go hand in hand. Once you calculate the configuration, you can easily fill in these box diagrams. These are orbital diagrams. And first, what you need is obviously the configuration. Now, I've given you a list of that, so make sure you have that out. I'm going to ask that you follow that because it's the easiest thing. Remember that they do have the noble gas abbreviations. You're gonna have to work around that. You're gonna have to use the long version to fill in these boxes. And basically what you're doing is you're drawing boxes and you're filling them in with arrows. That's the simplest thing to remember. Now, this will go hand in hand with that. Remember, S is 1, the P block has 3, D has 5, and then F has 7. That's how many boxes you're gonna draw for every orbital. So every time you see an S sublevel, you're just gonna draw one box. Every time you see a P sublevel, you're going to draw 3 boxes. When you see a D sublevel, you're gonna draw 5 boxes, and then of course F, you're gonna draw 7 boxes. Most of your worksheets will have the boxes drawn for you. You don't have to do that. It actually is a hassle to draw the boxes straight and evenly. It took me a while. But most of your worksheets and quizzes in real life will have that drawn for you. You're gonna have a homework assignment where you're gonna have to draw these on your own. Simple, it's not an art project, but make sure you do it correctly. So, once again, make sure you note the number of boxes per sublevel. It goes hand in hand with the numbers there. Then you're gonna notice that every single box is gonna have a maximum of 2 arrows. Remember, every single sublevel can carry up to 2 electrons, so you're gonna have 2 different arrows. So I just put here an example of the first 2 configurations. We have hydrogen and then we have helium. Remember, hydrogen is 1s1, 1 as your quantum number, which tells you the principal energy level. It also tells you what row it is in. It also tells you the sublevel based on the S. It's a spherical orbital, and then it tells you it's only 1 electron within that. So what you're gonna do is you're gonna draw the first box and you're gonna draw 1 arrow for it because there's only 1 electron within that configuration. 1 arrow. Then we move on to helium. Remember, it's also using the quantum number 1 because it's in row 1. It's in the first principal energy level. It's also using S because it's part of the S block. And then remember that helium has 2 electrons. Remember, every single element will have a different amount of electrons and a different amount or number of protons. That's important. We've learned that already because helium has 2 electrons, you're gonna have 2 arrows. We're gonna talk a little bit about 3 general rules when it comes to writing the orbitals within the boxes, but I do wanna make a note for you to notice that the arrows are facing opposite directions. That's one of the rules. Very easy to remember. I don't think hardly any of you will make that mistake, but you do have to catch those mistakes on worksheets. It's gonna ask you what error is being committed in this particular box diagram or orbital diagram, and sometimes the arrows will be facing the same direction, and that's simply just the small error. So make sure that you make note of that. This is for the 1s orbitals. What you typically would do, I put it here at the top. You'll see here in the other example there at the bottom. It doesn't really matter, but you do need to label every single orbital. So this is 1s. Both of these are 1s, and that's what you begin with. So make sure you label them either at the top or at the bottom of the box so that when you write these out, you don't get confused and you don't have to recount them because they do get longer, as you'll see. So remember, once again, S, P, D, and F, the amount of boxes that you have. I have 2 examples for you that will show you the 3 rules that you need in order to understand these. By the end of this, in case I forget to remind you, your homework assignment is to write out the orbitals from the box diagrams from elements 1 through 20, and they're very easy. These are the first 2. They're gonna be drawn in rows like that. You only draw the boxes you need. So for hydrogen, you don't have to go all the way with all the boxes. You know you only need 1 box, which is the 1s orbital. So based on that, you're just gonna draw 1 box. And then helium is also gonna need 1 box. Once you get to lithium, which is your 3rd element, you're gonna have to draw a 2nd box. Remember, lithium is in the 2s. You use that configuration based on what you did yesterday for homework and based on that list. So in case this is not making sense, you need to refer to that and pay attention to that. So I have two elements up here that we're gonna use as an example. We got magnesium and phosphorus. Magnesium, as you can see, has the chemical symbol of Mg and it's element number 12, excuse me. Then phosphorus has the chemical symbol of P, and then that's element number 15. We got two different diagrams. Notice how they look similar because phosphorus is longer. It has a longer box orbital with its configuration, but the rules still apply. So I want you to notice how this would be hydrogen, this would be helium, lithium, beryllium. You're gonna have basically 12 arrows for magnesium because there are 12 electrons. In case they give you an orbital diagram or a box diagram and it tells you name the element that is represented by this, you're just gonna count the arrows basically. And here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 arrows, therefore it's element number 12. You look at your periodic table, atomic number 12 is magnesium. That's easy. If you're working the other way and it tells you write the orbital diagram or the box diagram for magnesium, you're just gonna follow the steps. Remember, every S is only one box with two arrows. So we got one S, it's completely filled. We got two arrows in it. We got 2S, also completely filled, another 2 arrows. You're currently at element number 4. We want to get up to 12. Now remember that with P, you have to have 3 boxes. Always draw the 3 boxes no matter what. The S's go by themselves, P's have 3s, D's have 5, and then F has 7. You have to draw all of the box, all of the block, even if it's not going to get filled in completely, or at least you don't think so. I'll tell you why it's important here in a second. So you're gonna draw the 3 boxes for P and you're gonna fill it in because as you already know, you have 4 right here, plus the 6 you're gonna have within this box is still 10. You're gonna be missing 2 more because you're looking for element number 12. So currently with the 1s, 2s, and the 2p, you only have 10 arrows or 10 electrons. Then you're gonna need the 3s box. Again, you're just following along with the configuration you've already written out. If you haven't written them out, they're also in that list that I gave you. With that being said, with writing the 3s orbital, that completes 12. So you have 1, 2, 3, 4 in the first 2, and then you have 6 in that block, and then you have, so that's 10, and then in your 3s orbital, you have 2 more. So that's a total of 12. Pretty simple. This is the box diagram or the orbital diagram for magnesium. 12 arrows. Want you to notice, we've already talked about it, all of the arrows are facing opposite directions. That is important. Those are significant in their spins. That's what it's called. Every electron has to have opposing spins when it comes to their rotation, and therefore they are represented by those arrows. Always make sure, please remember, that your arrows are facing opposite direction. That is called the Pauli exclusion principle. Now, most of this information is in the worksheets that you should have in front of you. That term is in front of you, so I'm not gonna define it on the board and give you a long definition because I'm explaining it to you. It's your job to look into that and say, okay, that's Pauli exclusion, that's the name, that's how you apply it. I'm telling you now, Pauli exclusion principle is the one that will tell you you have to have opposing spins. The arrows have to be opposite. That's the Pauli exclusion principle. Then we have the Aufbau rule. Aufbau rule is going to tell me that I always have to fill the lower levels of energy before I can move on. And this is almost common sense. When you see it, you're gonna notice that something's wrong. I cannot fill in 2s until 1s is completely filled. I cannot start filling in 2p before 1s and 2s are completely filled. That's generally the explanation of the Aufbau rule. The first sublevels always get filled in completely before I move on to the next one. And that's almost self-explanatory. You have to make sure that you fill in the first sublevels before you move on completely. That is the Aufbau rule. That applies to every single configuration and diagram you're going to draw. So that's Aufbau. Remember, your arrows have to have opposite spins based on the Pauli exclusion principle. Let's move on to the next one so I can show you the third rule and then we're done. This is phosphorus, element number 15. Remember the one up here, how it's magnesium and it's 12. So up until here, it's already magnesium. Remember that. There's 12 arrows up until here. It's the same one being copied down here. If it's 12 and you want to go to 15, you're only going to need 3 more arrows or 3 more electrons in order for it to be phosphorus. So I do need my 1s, my 2s, my 2p, and my 3s in that order specifically. Remember, I'm already following my off-bow rule, which tells me I have to fill these in completely before I move on to the next sublevel. I'm also following my rule that tells me the Pauli exclusion, that all of the arrows are in opposite directions. My final rule is called Hund's rule. Hund's rule, and I hope you can see that down there. H-U-N-D-S, Hund's rule. Hund's rule will tell me that I must fill them in halfway before I fill in the entire sublevel. Basically, what that means is I cannot start filling in the 3p, the first little orbital box that I have, with both arrows until all of the boxes have at least 1 arrow. Now, don't allow that to confuse you with off-bow rule. That's telling me I can move on to the next orbital or the next sublevel before I fill in the first one completely. Notice how these are still within the same box or the same sublevel, 3p. I just have to fill them in halfway before I fill the first one in completely. And that is in order to maintain stability when it comes to the electrons. And we'll talk about that later on. That's for stability. It's more stable to fill it in this way than to start filling in 2 arrows before each little box has 1 arrow. So kind of to condense it down, I gotta fill in with 1 arrow the entire sublevel before I start adding a second arrow. So this is the correct configuration or box diagram for phosphorus. Most people, when they don't understand this yet, will want to put 1 arrow here and then 1 there, which means that they still have 15 arrows, but they're placed incorrectly. Do not do that. Give each box 1 arrow before you give the first one a second one. That's as simple as it gets. So let me recap these and then we're done. Once again, you're going to draw boxes for your box diagrams or your orbital diagrams, and you're gonna start with the first sublevel always first. It always starts with that. For the first 20, I don't want you to abbreviate. You're gonna learn how to abbreviate later on. You can still use the noble gases and in brackets and stuff like that. I don't want you to do that. I want you to practice. It's only 20 of them. And as you'll notice, the next one is just gonna be the previous one with 1 more electron, 1 more arrow. It's gonna get simple once you start practicing them. So always make sure you start with the first sublevel. That's my off-bow rule. Fill it in completely before I move on to the next sublevel. Then make sure that every one of the electrons has an opposing spin or arrows facing in different directions. That is my Pauli exclusion principle. Then make sure that if I have diagrams where they have more than 1 box, for example, P, D, and F, then I give 1 arrow to each one before I give a second arrow to the first one. And again, that's important for stability. So take a good long look at both of these, and I want to make sure that you understand the different rules. The arrows are pointing. I want you to know the difference. 3S, because it's just 1 single block, it doesn't matter if you only have 1 arrow or 2, it's just 1 box anyway. So you don't have to worry about filling in the rest of the sublevel because the sublevel is confined to just 1 anyways. We're talking about P, D, and F when we get to that. You're not gonna work with the D or F block yet because it stops at 20, but I want you to practice writing out these box diagrams as well. That's your homework before the worksheets. If you finish and you say, I think I got the hang of this and I understand the worksheets, go ahead and work on that, turn them in. If you are done, if you're completely comfortable with this, that's okay. A lot of you are smart and I think you'll get this, but 1 step at a time in order for all of us to understand. Note the number of boxes that you'll have every time you write P. Make sure you have 3 boxes. Remember, you're gonna fill them in completely anyway before you move on to the first box again with at least 1 arrow. So make sure that you draw all of the boxes so you don't forget that. Same thing for D and then same thing for F. Make sure you follow these 3 rules. These are gonna come up on a quiz. I would pay attention to the names and when they are being applied. Off-bow rule, first sublevels are filled in completely before I move on to the next one. Pauli exclusion, opposing spins, arrows facing different directions. Hund's rule, make sure you fill it in halfway before you start from the beginning filling it in completely, okay? So once again, make sure you take time to practice this. do both homework assignments, send them in to me. Do not worry so much about the worksheets until you're completely comfortable with them. I'm willing to open up the window of turning it in as long as the work is getting done. You're reaching out with any questions or concerns.